Good morning, children. Welcome back to ICAN Physics. We successfully completed the first lesson by solving 25 objectives. Okay. Now, we are successfully stepped into the next lesson, current electricity. From today onwards, we are going to give the video from the second lesson. Let's enjoy. Okay. Okay, children. Now we are going to see the second lesson, current electricity. Okay. Here, a charge 60 coulomb. Okay. So in the first lesson, we have seen so many things about the charge. Okay. So passes through the electric lamp. Okay. In 2 minutes. Okay. So the time is given. T equal to 2 minutes. Convert the time into its fundamental unit. Okay. So 2 into 1 minute, it has 60 seconds. Okay. The current in the lamp is, okay. Then a charge of 60 coulomb. So charge equal to 60 coulomb. So to relate current, charge and time. Okay. Current equal to Q by T. Okay. So what is Q? 60. Okay. So what is the value of time? 2 into 60. So now 60 and 60 getting cancelled. Okay. So 1 by 2. So 1 by 2 is 0.5. Okay. Current. The unit of current is ampere. Okay. Do you get it now? Okay, fine. Now, we are going to see about the word current. Okay. So, what is current? Current is rate of flow of charges. Rate of flow of charges through the cross-sectional area of the conductor. Okay. So, conductor. In the first lesson itself, we have studied about the conductor. Nearly all the metals, human body and earth are examples for conductor. Okay. So nearly all the metals. So I wanted to go to take iron. So iron 2656. Okay. So in iron 2656, there are 26 electrons. Okay. So we are having 26 electrons. Where these electrons can be. Okay. So we know that in K cell, it can occupy 2 electrons. Then it can be calculated by 2n squared formula. Suppose n equal to 1, 2 into 1 squared. So 2 electrons in K shell. Okay. So 2 electrons in K shell. N equal to 2. So 2 into 2 squared. So 2 2s are 4, 4 2s are 8. 8 electrons in L cell. Then n equal to 3. So 2 into 3 squared. So 3 3s are 9. 9 2s are 18. 18 electrons in M cell. Suppose n equal to 4. So 2 into 4 squared. So 4 4s are 16. 16 2s are 32. Electrons in N shell. Okay. So now we are having 26 electrons. Among that, 2 electrons can occupy in the K cell. So that we are having 24 electrons. Okay. The second orbit is L. In L, it can occupy 8 electrons. So the remaining is 16 electrons. In M shell can hold 18 electrons. But we are having only 16 electrons. So from that what we can say, the nucleus is at the center. Yes, the first orbit is K. In K, 2 electrons can revolve. Okay, fine. Next, the L cell can hold 8 electrons. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Next, in M cell, it can hold 18 electrons, but we are having only 16. So that 2 of the space is empty. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now what happens? The electron which is nearby that can go and occupy the position, then this place may be empty. Now, this electron may go and this place may be empty. At the same time, the electron may go and occupy the space and this space becomes free. Like that, the electrons are revolving. Electrons are revolving within the orbit. Okay. So when we are having a rod like this, okay, so it can be taken as x, y of length L. So in this rod, there are millions of atoms and billions of free electrons. Now we are using the word free electron. Why we are saying free electron? So in case L can hold 2, it is occupied by 2. L can hold 8, it is occupied by 8. So K and L is completely filled. Completely filled. So when these electrons are completely filled, so it is tightly bound with the nucleus. They can't move freely. Okay. These 16 electrons are partially filled. Partially filled. These partially filled electrons are called free electrons. Free electrons. The completely filled electrons are called core electrons. Okay, so these free electrons are otherwise called valence electron. So these free electrons are in billions of amount in a single rod. Okay, so 1, 2, 3. It may be one atom. Here 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Like that. Like that. There may be so many atoms. So the electrons, here we are having 2 free space. So 2 of the electron from the neighboring atom comes to this space. Automatically, here we are having 1, 2, 3, 4. 4 free space. Suppose 2 electrons from that come and occupy. Here we are having 6. So 6 of the electron at the time it goes and occupy. So here we are having empty space. Here the electrons are moving among the atoms. When they are moving among the atoms, how it is moving? They are moving randomly. They are moving randomly. So when they are moving randomly, how we can denote? In upper side maybe left, right, like that it goes. So when the electrons are moving randomly, then the net flow is 0. The net flow is 0. Then the current is also 0. Okay. So what we said, the flow of charges is called a current. Here also there is flow of charges, but here we are saying the current is 0. Why? The current is flowing randomly. Okay, fine. Next, when the charges can flow in the same direction. Okay. So let us consider the conductor X, Y of length L when it is connected with the battery or the external source. The external source gives an EMF. So when this EMF gives the electric field in the direction of X to Y, then the electrons are aligned in the particular direction. Here they are aligned in the particular direction. So there may be a net flow of charges, then it is said to be current. Okay. So just see that XY is the conductor. So like that I am putting the symbol. Okay. So what is current? Current is defined as rate of flow of charges through the cross-sectional area of the conductor. Okay. Do you get it now? Okay, fine.